we want to look at law of sines and cosines as it relates to triangles. The common way I'm going to designate triangles, well, let me just write, so law of sines and also law of cosines. So this is all about triangles, not right triangles like we've been using a lot until now, just any kind of triangle. Let's just do some definitions so as we work. So here's a standard triangle. Remember what we're going to do. Of course, you have three angles. I'm going to normally call the angles A, B, and C, and these are capital letters. And then what I'm going to do is the side opposite the angle. In other words, this side is opposite angle A. I call the length of that side little a. The side opposite angle B, we call that little b, and the side opposite C we call little c. Now the C's are the ones that can sometimes be confusing because they look the same except for the size. A's and B's are nice because actually they look different, so they're not going to be confused ever. So this is a typical triangle, but we will also have triangles that may look like this, where we have an obtuse angle, where one of the angles is like larger than 90 degrees. So I would call that angle A, and this is side A. I could call this angle B and side B, and angle C and side C. All right, so either kind of angle is acceptable. Notice that triangle really has six parts to it. 3 angles, and 3 sides. And what we're going to see now is that if we're given any 3 parts of a triangle, then we'll be able to determine the rest of the triangle. So given 3 parts of a triangle, we can calculate the rest. So a triangle has 6 parts to it. If we're given 3 parts, maybe we're given 2 angles on one side, or a side and 2 angles, or something like that. If we're given it 3 parts of a triangle, we can figure out all the parts of the triangle. However, there is one exception. If you're ever given a triangle and you're told of 3 angles, we cannot determine the length of the sides of that triangle. As it turns out, you can have 2 different triangles have the same 3 angles. Just the sides change. I mean, you can think about it. There's a triangle. And if just for fun, I drew another triangle outside of it. The 3 angles here are the same as the 3 angles here. But the lengths of the sides are different. So actually this is the one case, if you're ever given 3 angles of a triangle, you're stuck. You can't determine anything. But for everything else, and let's see what those possibilities are. We can have You can be given three sides of a triangle, and we can figure out all the 6 parts of the triangle. You can be given 2 sides and 1 angle, and we can determine what the triangle is. Or you can be given 1 side and 2 angles. So what we want to do now is go through. We're going to do this one first. So we're going to talk about, if you're given information on the triangle and you're given 2 angles on a side, we're going to go through how to determine the rest of the triangle. And then secondly, we'll talk about the situation where you're given 2 sides of a triangle and 1 of the angles, and how to calculate that. And then lastly, we'll talk about if you're given 3 sides of a triangle. Now we are going to talk about law of sines and cosines, and those are the main ways we're going to figure out these triangles. But one key that we use a lot, that you probably already know, is that the 3 angles, so this A, B, and C, are the 3 angles of the triangle. Can't forget that the 3 angles of a triangle always add up to 180 degrees. And just let me make a note, as it turns out, as we're doing all this work with triangles, we work exclusively with angles measured in degrees. I know up until now we've done a lot of work with angles measured in radians, but now we're back to just degrees for these triangles. So if you like your angles in degrees, then you'll enjoy this part of trigonometry. So don't forget, and we're going to use this, that the 3 angles of a triangle always equal 180 degrees, which basically means if you're given 2 angles of the triangle, obviously you can always determine the 3rd angle. So let's dive in, and we're going to first look at the situation where you're given 1 side, or how about this? Let me get a new sheet of paper. The first kind of triangle to solve, let's just say you're given 2 angles and 1 side. Now if we're given 2 angles on 1 side, it's pretty straightforward. We're going to end up using the law of sines. So let's take a minute. Let's see what the law of sines is and how it's used. There's different ways to write it. Let me try writing it this way, which might be easier. The law of sines let me just give you an example of one of the law of sines. The law of sines is a relationship between the A parts of the triangle and the B parts. In other words, sine of angle A over A equals sine of angle B over B. You notice there's no C's in here, it's just A and B. But of course, instead of B, we could say sine of angle A over side A is equal to sine of angle C over C. And finally, common sense probably says we could pair up the B's and the C's. So there are 3 different sort of applications of the law of sines. It's basically you're taking 2 angles and the 2 corresponding sides. It's just a pretty straightforward relationship. So how does that work? Well, let's just do an example. Say I'm given a triangle. And the whole key actually to solving these triangles is when you're given the initial information, the whole key to being successful with this is recognition. As soon as you're given the information of the problem, you need to stop and recognize what you've been given in terms of angles and sides. And once you recognize what you've been given, then that will determine how you're going to go about solving that triangle. So for instance, this triangle, they tell us angle A is 31 degrees, angle C is 76 degrees, and then they give us the length of side C, which is 19. There's no units here. It could be inches, feet, meters, or whatever. It's not very important for this. So given these three parts of this triangle, they want us to determine the rest of the triangle. So what's missing? Well, we need to figure out angle B, we need to figure out side A and side B. Now I want you to recognize, sort of important, what we have. We have angle A, angle C, and side C. From now on, whenever we're given, when our initial data, our initial information has the same letter like angle C and side C, I call that like a matching pair because they sort of match. That's just, you're going to hear me say that as a way to indicate when I say we have a matching pair, that means we know both the angle for that letter and the side. In a minute, I'm going to do a problem where we don't have a matching pair. But in this case, we do, because we know angle C and side C. Well, the first thing I'm going to do is, since I have two angles, and I want to find angle B, easiest thing is just to say angle B is going to be 180 degrees minus angle A minus angle C, right? I mean, this is, I'll write it again here just to be totally clear, right? The three angles add up to 180. If I solve this for B, so if I put in the information I have, A is 31 degrees, C is 76 degrees. I could do this in my head, but sometimes I find that I mess up. So let me go and use my calculator. Turns out angle B is going to be 73 degrees. Now I need to figure out these two sides. And this is where I'm going to use the law of sines. If I need to figure out side A, obviously, I'm going to use a law of sines that involves sine A over A. So now you might wonder, should I do it with B or C? Well, if I do it with B, I'm going to be in trouble because I don't know side B. I have to do it with the letter that I know both the angle and the side. I know angle C, I know side C, so that's what I'm going to use for my law of sines. And as it turns out, we know three of these things. I know angle A, I know angle C, I know side C, and that leaves only one unknown, side A, which I can now solve for. So if I just plug in the information, sine A is going to be sine of 31 degrees over side A. I don't know side A, that's what I'm trying to solve for. Sine C, sine of 76 degrees over side C, which is 19. So you notice by using the law of sines with A and C, I know everything but side A. So I'm going to rewrite this equation and solve for A. Easiest thing might be to cross multiply. Anytime you have two fractions equal, you can just say A times the sine of 76 degrees equals 19 times the sine of 31 degrees. So to solve for A, 19 times the sine of 31 degrees over the sine of 76 degrees. So you grab your calculator, make sure it's set up into degree mode. Sine of 31 degrees divided by sine of 76 degrees times 19. And I get side A is a length of 10.1. Now the only thing left is to get side B. And really I have a choice for law of sines. I can pair B up with A or with C. I'll just do it with C again. So basically I'm going to say sine of angle B over B equals sine of angle C over C. Once again, I know 3 out of these 4, because I know angle B is 73 degrees, so sine of 73 degrees over B equals sine of angle C, which is 76 degrees, over side C, which is 19. So if I cross multiply and solve for B, I'm going to have 19 times the sine of 73 degrees over the sine of 76 degrees. So once again, I grab my calculator. Sine of 73 divided by the sine of 76 times 19. Let me check. I worked out the answer prior to this, so I didn't get same. Let me make sure. Once again, I skipped some steps in here. I believe that's right. Maybe I just maybe I messed up on my calculator. Let me try it again. So 73 the sine divided by 76 the sine times 19. I'm a little worried because this isn't what I have in my notes. Maybe my notes are wrong. This is what you do. Let me just talk out loud. So all right, B is 73 degrees, and then C is 76 degrees. All right, this looks correct to me. For some reason, if after the fact I find I've got a mistake here, I'll try and come back in a future video and reference it. So, assuming I haven't made a mistake that I don't see, for this triangle, I can say angle A is 31 degrees, angle B is 73 degrees. Angle C, 76 degrees. Side A is a length of 10.1. Side B, which I'm a little worried about, but I'll take a look at this later and make sure I didn't mess up. And then side C is going to be, where did I do side C? Oh, I was given side C initially as 19. So there's our triangle. Now let me do one more example. If we're given a triangle where we're given two sides and one angle. Now let's compare it with this first problem. First problem, we were given angle A, angle C, and side C. Once again, I have this matching pair. Now you're going to see this problem's a little different in that we're given angle A, (122.1 degrees), angle B, 24.3 degrees, and side C is a length of 102. So I do have two angles and one side, except I don't have what I call a matching pair. I've got angle A, angle B, and side C. Well, this is not a problem because, you know, to use law of sines, I need to have a matching pair. I need to know the angle and the side both to use law of sines. But I can quickly figure it out because knowing the two angles of the triangle, I can take 180 degrees minus those two angles, and I can easily determine angle C. Once again, the three angles of a triangle, if you add together all the three angles of a triangle, equals 180. So angle C is going to be 180 minus 122.1 minus 24.3, and that equals 33.6 degrees. So based upon that, I can now start using sine C over C to go figure out sides A and B. Let's just do A first. So law of sines, sine C over C equals sine A over A. If I plug in all the numbers, so sine of angle C, sine of 33.6 degrees. Side C is 102. Sine of angle A, 122.1 degrees. And we're solving for the length of side A. Once again, to rearrange this, if I'm careful not to make any mistakes, I believe it's 102 times the sine of 122.1 degrees over the sine of 33.6 degrees. If I grab my calculator, sine of 122.1 divided by sine of 33.6 equals times 102. And looks like side A is 156.1. And now the only thing left is to get side B. I'll just do the same thing. Sine C over C is not equal to sine of angle B over B. Fill in the numbers. For C, sine of 33.6 degrees over 102. Now angle B is 24.3 degrees over the side B. So B is going to be 102 times sine of 24.3 degrees over the sine 33.6 degrees. So I'll let my calculator help me. 24.3 sine divided by 33.6 sine equals times 102. Looks like 75.8. So in summary, angle A is 122.1 degrees. Angle B is 24.3 degrees. Angle C is 33.6 degrees. Side A, we calculated 156.1. Side B, 75.8. And side C we were given as 102. So once again, there are the 6 parts of the triangle. All right, so not too bad. So remember, when you're ever given a triangle and you're given 2 angles on one side, it's just a pretty straightforward application of the law of sines.